HPLC stands for High Performance Liquid Chromatography, but could equally well stand for High Pressure Liquid Chromatography. It is used for separating mixtures, either to analyse the mixture or to separate a required product from others in a reaction mixture. It can also be used to find the relative amounts of different components in a mixture. HPLC works on the same principle as paper chromatography, here shown speeded up. A liquid, called the mobile phase, moves past a solid, the stationary phase. In paper chromatography, this stationary phase consists of water molecules bound to the cellulose in the paper. The mobile phase carries different components of a mixture, called the sample, along with it at different rates. How fast each one moves depends on its relative affinity for the mobile and the stationary phases. For example, if the mobile phase is more polar than the stationary phase, the more polar components of a mixture will tend to move more quickly than the less polar ones. In HPLC, the stationary phase is a solid packed into a column, like one of these. This particular column contains silica particles to which C8 hydrocarbons are attached, making the stationary phase non-polar. In paper chromatography, the solvent moves along the paper by capillary action. In HPLC, the liquid is forced through the column by high-pressure pumps. The whole apparatus looks like this. These bottles contain solvents. Two solvents can be mixed in any proportions to give a mixture, the liquid phase, of suitable polarity for the separation that is being done. In this case, one solvent is water, very polar, and the other ethane nitrile, less polar. The operator can decide on a mixture with the correct polarity for the separation she is doing. These are the pumps. They produce a pressure of 15,000 kilopascals, 150 times that of the atmosphere, hence the name high-pressure liquid chromatography. If a single sample is to be run, it is injected into the solvent stream here, in the injection port, via a hypodermic syringe. Alternatively, several samples can be run in succession by loading them into this auto-sampler, which will run them in order without any human intervention. The pumps force the mixed solvents through the column. The solvent emerging from the column and carrying the separated components of the mixture passes into the detector. Here, a beam of ultraviolet light shines through it. This light is set at a wavelength that is absorbed by all the components to be separated. When the detector reading drops, a component that is absorbing UV light is coming out of the column and passing through the detector. Many alternative types of detector are possible. This one measures refractive index. The time that each component takes to come off the column is called its retention time and can be used to help identify it. Here, the HPLC instrument is being used to separate a mixture of two steroids used in a pharmaceutical preparation. The column chosen is packed with a non-polar solid. The tails of the molecules represent hydrocarbon chains C8H17. Having chosen the solvents, detector wavelength and flow rate, a single sample is run by injecting about 20 microliters into the injection port. The more polar component comes off the column first, followed by the less polar. The peak at retention time, 1.5 minutes, represents other ingredients used in formulating the product. This is the pharmaceutical product, and behind it, its chromatogram.